Module 12, Lesson 7 is the volume of cones. Once again, we have what's promised to be a short lesson at 45 minutes. If we take and click up and start the pacing or the show, it says we have 12 resources to get through. Hayden and Chad are filling conical or cone-shaped bags with different types of treats. Hayden is filling the bags with popcorn, and Chad is filling the bag with jelly beans. Hayden knows that more jelly beans fit into one treat bag than the popcorn, but she wonders how much more. Suppose you knew the volume of one of the conical treat bags and the volume of one jelly bean and one piece of popcorn. How can you use this information to compare the number of jelly beans and the number of pieces of popcorn that will fit in a bag? Assuming, of course, there's no gaps between each of the treats. That's kind of hard to do with popcorn. I'm just saying here, guys. Anyhow, these are the kind of things we're going to be learning about in today's lesson. We're going to start off with the definition. A cone, you should know, ice cream cone, okay? You know this stuff, guys. Is a three-dimensional figure with one circular base connected with curved surface at a single point called an apex. So we're going to hit that and color it green. In the Explore activity, you're going to learn that there is a relationship between the volume of the cone and a cylinder with a base of the same height. The volume of the cone is 1/3 of the volume of a cylinder. That makes it pretty darn simple, with the same height and the same base area and height. So in words, we can take and say the volume of a cone with a radius r is 1/3 the area of the base area, times the height. Looking at a model of that, we're talking about we have a radius here and a height there, and the actual formula that we're going to be using, you can either use volume is equal to 1/3 times the base area times height, or you can say, you know what, base area, that's just going to be pi times radius squared because it's a circle, so we're going to use volume is equal to 1/3 times pi times radius squared. I suppose I will settle on using this one that the textbook's using because they seem to like that pi button an awful lot. Example 1, we have this cone here. It has a radius of 3 and a height of 6, and they want us to find the volume of it. So going through it the way they suggest, they put in their formula, pi 1/3 times pi times radius squared times the height. And come on, baby, load up. All right, we're going to move through some steps here. First thing they did is they plugged in what they knew. They knew the radius was 3 and the height was 6. They got that right here out of their drawing. From here, 3 squared, that's going to equal to 9. And 9 times 6 is the 54 that you have right here. Now, I would work mine slightly different, but there's nothing wrong with what they're doing here. Next, they're going to say, I'm guessing 1/3 of 54. Yep, 1/3 times 54. Also known as 54 divided by 3. That's going to equal to 18. So they have a volume of 18 pi. And finally, they wanted to take and let me see how they wanted it to be expressed. Express it in terms of pi. So right there they did it. No reason for me to waste your time typing 18 pi right here. Now it's your turn. Go ahead and pause the video and attempt to do extra example number 1 on your own. It should be pretty straightforward, I think. They want your answer in terms of pi. Solve the problem. First thing I did is wrote my formula. I'm going to plug in what I know. Volume is equal to 1/3. They said to do it in terms of pi, so we're just going to put pi. The radius right here is 2, so that's times 2 squared. And the height right here is going to be 7 times 7. Volume is equal to 1/3 times pi times 2 times 2 is 4 times 7, meaning the volume is equal to 1/3 pi times 28. 28 divided by, I'm going to go ahead and multiply that 1/3 times the 28 now, but I'm not going to divide it all out yet. Instead, what I'm going to do is to rewrite this. So now I'm going to have pi times 28, or let's go do ahead and do that backwards. Let's do it like this. 28 pi divided by 3, because 1/3 of a number is the same thing as dividing that number by 3. Now I can take and do 28 divided by 3. I'm going to do it as a fraction or mixed number because I think that's what they're going to want. 23 goes into 28 9 times with 1 left over, so it's going to give me 9 1/3 pi, which is the answer I would put in because it's the most precise option. If you did 9.3 repeating, that's kind of hard to do. Let's see if they said to round it. They did not say to round it, so that means they want a fraction. 9 fraction 1/3, geometry, pi, and accept and check, and our answer checks. Easy math. For example number 2, we have a cone-shaped paper cup that's filled with water. The height of the cup is 9 centimeters, and the diameter, watch that, they give us the diameter of the cup is going to be 8 centimeters. So we need to find the radius first, which is of course going to be 4, half the diameter. Continuing on with the problem, they started off by writing their same formula, 1/3 times pi times radius squared. Pi times radius squared is your base area, and then multiplying all that times the height. Next, they plugged in what they knew. They had a diameter of 8, so they did a radius of 4, and the height, that is going to be 9 centimeters. So I'm going to put my 9 in here. Check that. I said check that. It checked. And from here, what they did, there's a whole bunch of things at one time. First, they said 4 times 4 is 16. Then they said 1/3 of 9 is 3. And then from there, they said the 16 times 3 is 48. And they might have done it different. They might have done 16 times 9 and then did 1/3 of that number. But either way, it's still going to give them 48 pi. And, then your answer, use a calculator. So we're going to take and grab our handy dandy calculator right here. We're going to do 48 times, hit my pi button right there, equals, and it's so rounded to the nearest tenth is going to be 150.8, 150.8. Check it, and the answer checks. Easy math. Now we're going to reset this one so it'll be ready when my students come to class, and you are going to pause the video and do extra example number 2 where you're dealing with a unicorn cone, just what everybody wants. It has a height of 8 inches, a diameter of 3 inches, and they want to know rounded to the nearest tenth. And I'm going to say probably want to use your calculator button for pi on this. I set up my formula as volume is equal to 1/3 pi times radius squared times the height. That's also known as 1/3 times the base area times the height. I'm going to plug in what I know. The 1/3 I'm going to leave alone. The pi I'm going to leave alone. My radius right here is 3 inches, so I'm going to have 3 squared, and my height right here is going to be 8. Now I can say volume is equal to 1/3 pi, and then 3 squared is going to be times 9 times 8. Now we can do something pretty cool right here to make our math a little bit simpler. I can take and simplify that 1/3 and the 9 by just simply saying 1/3 times 9, that's going to end up being 3. 1/3 of 9 is 3. 9 divided by 3 is 3. And then that's going to be times the 8 times the pi, and that's going to leave me with 24 pi. Now, of course, they wanted a final answer rounded to the nearest tenth. So we're going to grab our calculator, 24 times, click our pi button, hit enter, and that's going to give us to the nearest tenth, 75.4. 75.4, which is what we're going to plug into our textbook for our answer. Jump back over here, 75.4, check my answer, and my answer checks. That's going to be it for this lesson. Get busy working on your homework. Bring me your questions in class tomorrow.